G'day guys, Zach from High Performance Academy here. We've got an unboxing for you today on the Haltech NEXUS R5. We've got one of these here because we're putting together a new course on power distribution units, and we're going to be installing this unit in one of our race cars. They're a pretty hot commodity at the moment. They're actually pretty tricky to get your hands on. So we thought it'd be a good idea to whip one out of the box, have a quick talk about its features, how it's a little bit different to your standard ECU, where you might use it. We're not going to do a deep dive into the software today, but keep an eye out for our upcoming PMU course because we are going to be going into the software in that one. So standard unboxing affair, we'll just have a quick look at the packaging here. We've got corrugated cardboard. Pretty robust. I don't think this is going to be getting damaged in transit at all. Everything's packed nice and tightly. Now also standard unboxing thing is that yes, we have actually opened this before. I did need to get the unit out to sort of get it into the application that we're going to be using it in to make sure the mounting and connectors getting in there and everything was going to be okay. But I've repackaged it up and we'll go through everything in the box now so you know what you'll be getting. So straight away, we've got some lovely text here from Haltech's warning performance enhancing technology inside. So whether that's cheesy or not, I'll leave it up to you to decide. Knowing a little bit about Haltech, the company and the guys there, yeah, they're on the mark. They are doing great things for the industry and have a lot of their technology in real like class leading cars. So it's pretty cool stuff. Underneath here, straight away, we've got the unit on top. And first thing is, I was looking at my hands for scale here. It's pretty big. It's a hefty unit. And the reason for that is I haven't mentioned yet, well, I alluded to it by saying it's not your standard sort of vehicle ECU. This is your vehicle ECU, so it's going to control your complete engine management system for your EFI in your car, but it's also a power management unit or a power distribution unit, as they're sometimes called as well. So that means we're going to change its name and we're going to call it a vehicle control unit, a VCU. We're going to be able to do all our engine management tasks, all our EFI system control to get that engine really running nicely, but we're also going to be able to control all the other features in the vehicle. So that's things like cooling fans and fuel pumps, anything that you'd traditionally be using fuses and relays to send power to, we're going to be able to do that directly from the Haltech NEXUS itself. So I'll pop the unit off to the side just for the moment and we'll have a look at the other stuff that comes in the box here. On top here, a little bit of written documentation, which if you've watched any of our previous unboxings, you know I'm a bit of a fan of. We've got our quick start guide. So that's going to be all that relevant base information that we're going to need to know just to get up and running with the device. So I'd expect there'd be a list of all the features, everything we could expect to find in the box in here. And, oh, right in the middle here as well. That's quite nice. We've got a mounting template. And I reckon they've put that in the middle of the manual because we'll just be able to undo these staples and pull that out, put it in place in the vehicle and get all our drilling positions for the mounting holes on it. So that's pretty cool. I'm expecting there's probably going to be pinouts in here as well and some basic guides on wiring things up for common applications. So when you're next to the car and you're doing all your wiring and your configuration, you don't quite have your laptop next to you because its battery's gone flat, because they always do. Written documentation like this, really handy. So do like to see that. Product range. So they've given us a catalog of what else is out in their product range as well. Usually I'm just looking online for that information, but cool that it's in there. We've got another box in the front here, so open here. So we'll whip that out. Pop this off to one side and we'll have a look at the accessories that are going to come with the unit. So we'll open this up and there's going to be no graceful way of doing this. I'm just going to pour everything out and then we'll have a look at all the pieces. So having a look at the pieces we've got here. Some stickers for the toolbox, always great to see. I don't know about you, but my toolbox is absolutely littered with stickers and does look pretty good. Most of them pilfered from HPA, so that's excellent. We'll start with the cable here. So yellow, which is nice, slightly distinctive in the Haltech colouring scheme, so that's probably pretty cool to see. Also, if anyone pinches it, you're probably going to be able to see it hanging out of their toolbox as well and know that it's your cable and go and get it back, so that's good. It's USB Type-C, so this is a Type A to Type C cable. Not something I've actually seen on any ECUs that I've had anything to do with yet. Most are either a Type B connector or a micro connector, but they've got Type C on the NEXUS R5. It is still running USB 2 transmission speeds though, so that's 480 megabit per second. It's not up to the really high speeds of the USB-C standard, but they've gone to the physical USB-C standard, and what you get there is a cable that can be plugged in either way, which really is excellent, particularly if the Nexus is mounted in a slightly awkward to get to spot. You're going to be able to get the cable in nice and easily, so that's cool. There's also a wee dust shield cover in here for the USB-C type port on the Nexus, so if it's in a dusty environment, that's going to keep that port nice and clean. Next up here, we've got a Wi-Fi antenna. So that's something you might not be expecting to see in an automotive performance product. This is actually the first automotive performance product I will have had anything to do with that's got integrated Wi-Fi on it. So that is for connecting to the device to either download logs or actually configure it as well. The speed of the Wi-Fi is actually quite a bit more limited than the speed of the USB-C, and there is quite a bit of logging memory, which we'll talk about in a minute, on the device. So probably more for setup or a quick change of a parameter in the device as the car rolls into the pits, where you don't want to have to actually get into the car and physically plug into the ECU. If you're just doing like a quick change to some configuration setting, a boost limit or something like that, this could actually be really handy. Remains to be seen how stable it's going to be in sort of a quite noisy automotive pit environment, but I think if you're standing right next to the car, you're probably going to get a pretty good signal. The Wi-Fi, however, because there are security concerns around this, of course, can be locked out. So you can plug in with a USB Type-C cable and you can disable it, and it's a proper hardware disabling of the Wi-Fi chip. So there's no way it's going to be accidentally active without you knowing. The Nexus R5 works as an access point. So that means when you plug in, you configure it with an access point name and an SSID password, and that's how you're going to log into it. Moving right along, standard fasteners, so nice that they include those. Look like M6x1, good amount of length there to get through the unit, cap head with nylock nuts. Race cars are the definition of a high vibration environment, so nylock nuts are a total must there, so good to see they're included. Last up in that accessory box, we have these two connectors here. Which I'm quite excited to see actually, because they're really great connectors to work with, and they're absolutely the way that modern performance automotive vehicles are going when it comes to our high current direct to battery connectors. So we'll have a look at these in a little bit of detail. Red and black obviously being red for positive 12 volts, which is a direct connection to the battery in this situation, and black being a direct connection to the battery ground as well. So the reason I really like these connectors is that they're quite easy to work with, and they've got some really good features. When they're installed, they're sealed, so we're not going to see any ingress of dirt and moisture onto the device causing a dodgy connection here, which would lead to quite a lot of heat, which is something we don't want. I can just pull our black one apart here quickly and have a look at the back end here. So this threaded section here has an O-ring, so that's all sealed when it's installed, and we've got a white seal that's going to interface with the outside of our high current cable, and that's going to keep that sealed as well. Now, cable size for these connectors here is 50mm squared, or that's 1 AWG. So any of your standard cables in that size are going to fit nicely in here and interface with the seals on here well as well. Crimping these down, I suspect you could probably get away with a standard indent crimp, but the length here might actually lead to some slight deformation of this terminal up by the plastic molding here. So I'd be going for a hydraulic hex crimper on that. Absolutely, I suspect the less expensive hydraulic hex crimpers from the likes of AliExpress are going to be totally fine for this. To be honest, that's the hex crimper that I have in my toolkit, and it's not caused me any issues at all. I've always had really good, reliable crimps out of it. So it's going to give us a nice good hex crimp on that, really good connection to our 50mm squared cable. Working with that larger cable can actually be a wee bit tricky, and these connectors, which I don't know if I mentioned their specific name yet, which we'll go through now, they're called a RadSok. Hopefully that's coming up on the overhead there. There's a couple of different types of connectors of this. There's rad locks and there's rad socks, so you've got to be a wee bit sure about which one you're using, because I'm not 100% certain that they all intermate, so keep that in mind. The feature that I really like about these style of connectors is that once they're plugged in, they're still free to rotate. So when we're working with that larger gauge cable, that actually gives us a really good degree of flexibility there. And means when they're installed on the device, we're able to route that cable as we like. So yeah, I really like these, good to see. Becoming really common in bulkhead connectors on vehicles as well. So you can get this style of connector in a bulkhead pass-through that uses like a 4-bolt flange mounting system to bolt to your firewall, and really easy way to pass those high current battery cables for when the battery is installed inside the vehicle, like it really often is in race car applications. Cool, so I've probably fanboyed on enough about the RadSok connectors here. Do really like those though, and I'm really looking forward to actually using these when I install it in the vehicle. So the unit itself, just get that centered there. We'll have a look at this. Quick talk about its construction. On the top here, I'm assuming that this is a cast aluminium. I haven't read anywhere that said it was a magnesium or anything like that, but it's a really nice high quality unit here. The Haltech text that's embossed, I'm gonna say that was probably post-machined on there because it's very, very crisp on its edges. Really nice gunmetal metallic finish on this. It's a bit more matte, it's not glossy, so it's not going to show all those horrific fingerprints. Going to look really nice installed in your vehicle. Very, very professional race car appearance, which is nice. We've got our 2 RadSok connection points here, large color coding on there, so hopefully that's reasonably idiot proof when this is being connected. And as I said, when these connectors are in place, they're free to rotate, so our high current cables coming in there, lots of flexibility around how they're going to be orientated, whether they're both from one way, from either ways. You're going to be able to get a nice, tidy, clean install. Also on the top of the unit here, we've got some status LEDs, which there's a bit of an argument as to whether status LEDs on devices like this are actually required, because chances are all that information is going to be available on a CAN bus network and it can be displayed other places in the vehicle, like on the dash. I like having them though, because there's no downside to it, and if this is mounted in a place where it's easily visible, it's just a good visual check to look at that and go, yeah, I know that the high current output number 1 is currently switched on, or if that LED was red, it would mean it's had some sort of fault as well. And we'll talk a little bit more about that in a minute when we get into the power distribution module features of this device. But if one of these power outputs was, say, powering the dashboard, and the dashboard was where all your warnings were coming up, and that had a problem, so the dashboard wasn't on, well, you wouldn't be able to see your warnings. So having the LED indicators directly on the top of the unit here, pretty cool feature. We've also got some generic ones here, just looks like power for the device, a general purpose check engine, Wi-Fi connection, and I'm not sure what the last one is going to be, but I suspect it will probably be a logging LED, telling us the status of the logging. So whether that has, most commonly it's whether the logging is running, and then it's got a slightly different state for if the logging file is full and you need to download that and clear it out. Little thing that I do like are the counterboard mounting holes here. So when we put our cap head screws in that, they're going to sit nice and flush, so nothing's going to get caught on them. None of our cables are going to interfere with them at all. So do like to see that. Nice feature. Turning the device over, there's not too much going on in the back here. This is a matte black, but still feels like the same cast aluminium. We've just got our cap head mounting screws there, our cap head screws holding the device together. Mounting holes, of course, the Nexus R5, and I assume individual serial numbers, which could be handy for any troubleshooting that you might have to do with Haltech. Haltech have actually got pretty good customer support. If you've ever been using one of their devices, they're pretty easy to get a hold of, which is unfortunately not as common as I would like it to be in the automotive aftermarket. We've got pretty talented guys at HPA when it comes to setting this up, pretty good knowledge pool there, but you still quite often find yourself in a situation where you think, I'm not entirely certain how that particular feature totally works. So being able to call the manufacturer, get someone on the horn straight away and have a conversation about it, really important. So Haltech do a pretty good job of that. Business end here we'll have a look at. So we've got a lot going on here. She's a pretty busy device as far as our connectors go. So moving from my left to right here, Wi-Fi antenna connection, so we talked a wee bit about the Wi-Fi features before, so that's just where our antenna is going to go into place. You'd be able to buy a little cap for that as well if you weren't going to be using any of the Wi-Fi features and you didn't want the antenna there. I haven't seen a wee cap included, but maybe that would be a nice thing, because I can imagine that a lot of people aren't actually going to use the Wi-Fi, and you wouldn't want that getting filled up with dirt and grime, because I mean, race cars are pretty filthy environments, really. USB Type-C, as I mentioned, awesome, so connector can go in either way. That sounds like a really tiny thing, but the frustration of getting particularly USB micro connectors in place on devices, they can be quite fragile, and in the performance automotive environment, when you're wearing pit gloves, so you've lost a little bit of your dexterity there anyway, trying to get those in place, it's actually possible to do a bit of damage. I've seen plenty of damaged micro B ports, so I really think the Type-C just being a little bit more robust and being able to go in either way is going to help with that. I would have liked to see USB Type-C data transfer rates, but I suspect when they were doing the actual engineering on this device that all that was still probably pretty new. So it is just USB Type 2 transfer rates, but for what we're doing here, we're not talking about huge amounts of data, so it's not really going to be much of a hold-up. Continuing along, we have AMP Superseal 1.0 connector headers. So we've got a 34, a 26, a 34, and a 26. I'm not going to do the math off the top of my head, but that is a lot. It's a lot of pins. There is a lot going on here, and we will have a quick run through of what the pins do, all the features of the device, but she's pretty hefty on that front. I really like AMP Superseal 1.0 connectors. I find them very easy to work with. The tooling for them is quite inexpensive to do a really nice job of crimping the pins. Available from Haltech, you can buy this unit just as it is by itself like we've got here. You can buy it with pre-terminated general purpose harnesses. You can also buy it with just the connectors and the header pins for crimping onto your own harness as well. So as I mentioned, the tooling to do that, I'm pretty sure that's available from Haltech as well, or plenty of other places. Nice and inexpensive, good sealed connector, and just really easy to work with. So I do like that they've gone with the AMP Superseal 1.0s. On the end of the machine here, we've got a Deutsch DTP, so it's Deutsch's DT range of connectors, but P is for power. And you can see there we've got some pretty chunky pins in there. That's because this is a high current output port. Each one of those pins is capable of 25 amps output. So you've obviously got to have the corresponding wire size going into that to handle that current, which you can interface really nicely with the DTP 4-pin connector that would go in here. Comes with terminals that are obviously the right size to crimp onto that heavier gauge wire. I mentioned we'd have a quick talk about the features and why there's so many pins on this device, which we'll do now. I've had to write them down because there are so many that I could not remember them all. So I've got a bit of a list here. This is of course also information that's contained on their website, so you can look it up yourself if you're speccing a device like this for a particular project. Also in the quick start guide that comes with it as well. But starting with the engine control functions, the functionality you've got there around controlling an EFI system, we've got 18 peak and hold injector drivers. So that's a lot of injector drivers. Now they're capable of driving your standard saturated output, so that's just an injector that you turn on and don't do any current control on, or a peak and hold, which would be a low impedance injector that you drive open with a high current and then hold open with a lower current. Having 18 of those is it's a lot. A sequential injection setup on, say, well, a V8 is typically going to have 8 injectors, so that's leaving us 10 spare. That means we could actually put 8 more injectors on there, and we could run a staged injection setup where we've got 8 smaller injectors for when the engine is just idling around and cruising, and then we could have 8 much larger injectors, say if it was a forced induction application, that once the engine is really getting into the swing of things, going on song, it can bring those 8 larger injectors in and give it the fuel that it requires. Then we've also got a couple more, so maybe we might want to use those for an auxiliary fuel before the throttle body, might get some cooling out of that, possibly some other injection there as well. We could do 3 stages of injection on a 6-cylinder or 4 stages of injection on a 4-cylinder. There's a lot going on with our injector drivers there, so a lot of flexibility around that. Any of those drivers that don't get used for injectors can be used for other purposes as well, so that's good. We have 12 ignition outputs, so any of those, anything up to a 12-cylinder engine, we're going to be able to run in full sequential mode. That's pretty cool. 8 general purpose DPOs. So these are digital pulsed outputs in the Haltech lingo. They're essentially, in other ECU terms, just a general auxiliary output. So they're a low current, low side drive, and they're capable of PWM operation. So things like maybe cam control solenoids or boost control solenoids, idle air control valve, things like that are what you'll be hooking to those outputs. We've also got 4 half bridges. So a half bridge is an output that's actually 2 pins, and you can drive one of those pins high and one pin low, or you can swap it around and drive the other pin high and the other one low. That's a full bridge, which we make out of 2 half bridges. So we've got 4 half bridges. A half bridge is an output that you can drive high or you can drive low. When we combine 2 of those together, we get a full bridge, which when we hook into a circuit means we can drive one side high and one side low, or we can then flip the polarity on that and drive the other side high and the other side low. So we've got 2 full bridges. Why that's important is that you need a full bridge to drive a drive-by-wire throttle correctly. So we can drive 2 drive-by-wire throttles on this, which for a lot of V-banked engines makes intake manifold design, I'm not going to say more straightforward, but you're able to get more advanced with your intake manifold design having 2 throttles there. So that's our outputs for the engine control side of things. We've got our inputs on the engine control side of things as well. So we've got 2 dedicated trigger inputs. So most engines you're probably going to be setting a device like this up on are going to be running in sequential mode. That means there's going to need to be information going into the Haltech about not only engine position, which will come from our crank, usually a sensor mounted on the crank, but also engine phase, or sometimes it's called a home or a sync signal. And that tells the ECU which phase the engine is in, because a piston could be coming up on cylinder number 1, and that could be either on the compression or the exhaust stroke. So we're having both those sensors, one on the crank and one on the cam. The ECU knows exactly where it is in the full 720-degree cycle, so it can run everything sequentially. So 2 dedicated inputs for that. We've got 10 what are called synchronized pulsed inputs as well. So these are really fastly read inputs on the device. I think they're sampled at 1 million samples a second. So those inputs you can hook things like wheel speed sensors to that have a variable reluctant output, that AC waveform. So you're able to set that up for zero crossing triggering to get really reliable readings off things like wheel speed sensors. So we've got 10 of those. 2 dedicated knock inputs. Knock detection requires normally some pretty specific circuitry around that. So that's why they'll have that on 2 dedicated pins going into that. It's essentially an audio filtering and amplification problem to solve there. So they've probably got pretty good circuitry in there for taking care of that. 2 dedicated wideband controller inputs. So really thinking this device, they've absolutely thought about those V-engined examples, those V-engine setups, where you've got 2 exhaust manifolds, so you're more than likely going to have 2 O2 sensors. Dedicated wideband O2 sensors are becoming, wideband O2 sensors are becoming far more prevalent in devices like this, and that's great, because traditional wideband controllers that plumb that information back to the ECU on an analog voltage are subject to some discussion about how accurate those signals can actually be, and there can be quite a lot of setup in ensuring that things like that are correct. External modules that pipe that information back via a digital network like CAN, they're definitely a step in the right direction and they're much better, but having it integrated on the device itself is really nice. Those wideband inputs are able to interface with both Bosch LSU 4.9 and the NTK sensors as well, which apparently are much better in methanol applications. I've not actually ever used an NTK sensor, but I do understand that at the higher levels of motorsport, they're usually the choice. So there's got to be some reasons for that, and the Haltech can interface and drive those correctly and get a valid reading out of them as well. And then last on my list of engine management inputs here, but certainly not least, 23 0 to 5 volt analog general purpose inputs. which have software selectable pull-ups on them as well. So that's definitely one of the reasons we've got so many pins on here, because there's 23 0 to 5 volt inputs. So if you are hooking up things like engine coolant temperature sensors, they'll be on one of those channels, but you'll have a pull-up enabled for that to allow you to read just a resistive sensor, or engine oil pressure, fuel pressure, any of those pressure signals. Yeah, you'll be able to pipe a lot of sensor data into this with those 23 inputs there. That pretty much rounds it out for the engine control side of our Haltech NEXUS R5 here. I'll just flip over to my next page and we'll have a quick look at the thing that arguably makes the NEXUS R5 its crowning feature that makes it a little bit different in the market, and that is its inclusion of a power distribution module or a power management unit module in there as well. So in professional motorsports in particular, but also at the hobbyist level, there's been a big movement towards heading away from using fuses and relays to do all our power distribution to the parts of the electrical system in the vehicle, to solid state devices for doing this. So integrated modules that have solid state MOSFETs that do all the switching, and they're monitoring the current through all those channels. If anything goes out of spec, higher than a current level we've set, they can turn that output off. And then there's some good features around that because they can automatically retry it. So in an event that a device drew too much current, it got turned off, it might be possible to actually retry it, and maybe the blockage or jam that was causing it to draw too much current has actually abated now, and the device will start up again, an error will be logged. At the very least, it might let you limp the car back to the pits. Whereas a traditional setup with a fuse, if that fuse blows, the car very likely could end up dead on the side of the track until that fuse is replaced. So just brief overview there of why, like one of the reasons that moving to power management units is really prevalent at the moment. So really nice to see everything integrated in one unit here. Another key benefit around that is the simplification in wiring. Wiring up a traditional fuses and relay setup actually I think that's the hardest part of a wiring job in a motorsports application. Doing that tidily, there's a lot of connections to be made to all the individual relay pins, and if there's going to be a failure in a vehicle like that, that's typically where I'm going to find it. I think everybody's probably experienced a car not starting due to a slightly dodgy connection on a relay. The simplification in wiring with moving to a device like this really can't be understated. I'm designing a lot of wiring harnesses myself. I'm really looking forward to getting to grips with this because I'm going to be able to design the harness in a far easier way because I've just got our 4 AMP Superseal connectors here to worry about. So that's going to make that harness design process much easier. Now those outputs to actually drive our devices, these are the ones that are linked to on our LEDs on the top here, telling us whether those devices are on or off. We have 12, Haltech calls them their low current outputs. They are capable of 8 amps of current each, and they're a high side drive. They're also capable of being PWM switched at a maximum frequency of 100 Hertz. In the grand scheme of things, when you're actually wanting to PWM control outputs, 100 Hertz is not particularly high, so the use case for that might be a little bit limited. But just having 12 8 amp capable outputs that are high side drive is going to be really useful. So driving things like, simple things like the lights on the vehicle, being able to control those with the Nexus in response to keypad commands coming over a CAN bus, that's going to be really powerful, and it's going to simplify the overall installation in the system as a whole. The output current allowable on those channels is software definable. So you could define it to be the maximum of 8 amps. If more current than that is drawn, it will shut the output down. It will retry it a number of times that you can also configure. And if it continues to fail, it will just turn that output off. That 8 amp limit you can actually bring down quite a lot. I suspect there'll be settings to actually allow a higher current to flow for a short period of time. The 8 amp limit is in place because that is the specified limit for our AMP Superseal 1.0 connectors here. I would say the actual driving hardware, the actual switching MOSFETs inside this unit are probably capable of much more than that. The reason I say that, to just go full geek here for a second, is because they're allowing PWM operation, and PWM operation generates quite a lot of heat in any switching MOSFET when you're doing it. So I suspect those MOSFETs are quite over-spec'd for a constant 8 amp output. So we shouldn't be seeing any burnt out MOSFETs on the device at all. I did talk to Haltech about this at one stage, and they said they had tested it with all 12 outputs drawing 8 amps of current, as well as the high current outputs over here fully maxed out as well. So the device passing as much current as it could, and it was able to operate in that state for an indefinite amount of time. So that's really good. Moving along here, we've got our high current outputs. These are the ones that I am most excited about getting to grips with. So each one of these, there's 4 of them, and each one of them is capable of 25 amps of current output, but it's PWM switchable at 1000 Hertz. So that's going to give us speed control applications on things like fuel pumps, thermofans, electric water pumps, those high draw items that doing speed control on is actually not a trivial task to engineer into a device like this. As I mentioned before, when you're PWM switching a device, it generates a lot of heat, and to be able to PWM switch at 1000 Hertz with a 25 amp output, that's not trivial. So hats off to the engineer that has designed that into the device and got the thermal management right to make that work. Very, very cool. I'm really looking forward in particular to hooking up thermofans to that. There's a definable soft start feature as well. So soft start on something like this is when you're driving a motor or an inductive load, and when you turn it on, it initially PWM controls the device up to its full power draw, and then plateaus wherever you've set it. So you'll be able to turn thermofans on and avoid big inrush currents basically. So that's really cool to see as well. And the last thing we'll talk about today is the other integrated feature here. So often in a race car installation, you have an ECU controlling the engine, you've got a PMU or a PDU controlling the power supply to everything in the car, and you've got a logger logging all the signals so you can get that data logged at really high data rates. The Nexus R5 is the logger as well. And this is in particular something that I really like because I'm a big proponent of logging data at the source at which it was collected. So we've got lots of inputs on this, and being able to log those directly at the device means we're not going to strike any issues with loss of data rates because we had to transmit it via CAN and the CAN bus was overloaded or something like that. So logging at the device is really good. We've got 512 megabytes of logging in here, so that is quite a lot. That being said, we're capable of logging channels at up to 1000 Hertz, so a kilohertz. If each of those channels, if each piece of data is, I'm going to assume it'll be 4 bytes because that's pretty common, and we're logging those at 1000 Hertz, that data stacks up in size pretty quickly. So you will want to go through and do a little bit of a calculation to make sure you're not running out of logging space there. I suspect though that they're with 512 megabytes and a reasonable logging setup, because there's actually not many parameters that you need to log at 1000 Hertz, most of it's more around the 20 to 50 range, there's going to be hours of space there. So keeping logs of multiple outings on a track day, or if you're into endurance racing, you're going to have the space there to be able to log complete races, which is going to be really awesome. That higher data rate on the the data rate that's available on the USB connection there means it's 480 megabit per second, so that's about 60 megabytes per second. In an ideal world, maybe we'll call that 40, because I find USB is never actually as fast as you expect it to be. So we'll say 40 megabytes a second. That's actually not a lot of time to pull the entire log file out of this as well, so that's pretty cool. Along those lines, there's been a bit of a ongoing negative reaction to something in the Haltech world, particularly in the Elite Series ECUs. The connection time to actually connect your computer to those ECUs, in my experience, is quite long, possibly in the realm of 30 seconds. And that doesn't sound like much, but when you're having to do multiple little changes or a vehicle's just come into the pits, that can be a wee bit not the nicest thing to have to deal with. They have sorted it in the Nexus, and we've seen it connecting to the computer within a couple of seconds. So really awesome to see that as well. So a good bit of overview on the Haltech Nexus product there. We're certainly pretty pleased to have ours. I'm going to box all this back up now. It's going to go on the shelf, and in hopefully a couple of weeks we're going to get into the project of installing this in our little race car, and we'll be filming a worked example on the power management setup side of this for our upcoming power management course as well. So really looking forward to that. So thanks heaps for joining me on this one today. Hopefully you've got a bit more knowledge around the Haltech Nexus product, and make sure to check them out probably for your higher level motorsport products. I'm not going to call this an entry level product by any stretch of the imagination, but for those higher level motorsports applications, definitely worth your time to have a look.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.